Okay, welcome back, statisticians. I'm going to walk you through step by step the lab that we did in class on Thursday. Okay, so let me share my screen with you. Okay, I'm going to start by going to Laulima and going to the resources. Right, here are the resources. Go to handouts and references. This was also posted in the assignments, but here is, I put it here too. Lab Intro to R and RStudio docx. This is lab 1. Downloaded it. And now I'm going to go up to resources and I'm going to go to R scripts and data. And I'm going to download the Tuatara Islands R format XLSX data. I'm going to download that too. This is going to land over here in my downloads folder. All right, it's going to land over here in my downloads folder. I already downloaded it, so now I'm going to see two. So I'm going to delete the extra one. So now I've got Tuatara Islands R format and Lab 1 Intro to R and RStudio. So I'm going to start by opening up Lab 1 Intro to R and RStudio. And I can see you have this very nice document, which starts by giving you a link to install R and RStudio. Click there to follow the link if you haven't already installed it. And if you have installed it and it's not working, update it. I don't have a link to update it here, but you can find it online. I recommend Googling in update R from within RStudio, and there's this install R package that will just blast you through it, do it for you. It's great. It's really easy. It won't take that long. I think you have to stop RStudio and then restart it, but it's pretty easy to do. And if you've already got R installed, you've probably used R before and you can figure it out. If you're not sure how to do it, connect with me or Michelle, the TA, and we'll help you. Or use the class computers. Hopefully they should all be updated by next class. But here, I'm just going to start my RStudio right down here. And when I start it, it looks like this. Move this out of the way. When I start RStudio, it looks like this. I have a console. I have this environment tab, and then I have this window on the bottom right-hand side that says files, plots, packages, etc. Right? So if I wanted to, I could just type into this console, let's say 4 + 5, go, and I get 9. The trouble is that every time I want to make a change, I have to retype it. And that gets old pretty fast. So I'm going to make this smaller so that we can look at both screens. Look at both screens here and just go step by step through the instructions in this tutorial with you, okay? All right. So open RStudio. The first thing that I want you to do is to create an R script. You're going to create a new file within RStudio where you're going to write your code, and you can save it to make changes later or use it for later. All right. So you come up here, you go to File, New File, R script, or Control-Shift-M, right? And what that does is opens up a new window. Now you have 4 window panes. The upper left one is your R script. On the bottom left is your console. Upper right environment. Bottom right has files, plots, packages, a bunch of different things, right? So the first thing I want you to do before you go any further, listen to what I'm saying here. Save your R script. Save it before you go any further. Control S and name it. What are you going to name it? You're going to name it exactly what I told you to name it down here. You say, call it Intro to R and RStudio R script, and it's going to save it automatically as a .r file. Where are you going to save it? Well, that's up to you. It's where you choose to save it. I'm going to keep it in my biostats R labs folder. I'm going to put it here. I'm going to save it here. And I'm going to give it my name too, so that I know this was me that did this. All right. Okay. Now we can start coding. First of all, I want to tell you something about RStudio. RStudio is really handy. When I first started using RStudio didn't exist. There was just this console, and it was really, really complicated and difficult. RStudio made life so much easier. And one of the reasons it makes it easier is because you can make these script files that allow you to, save them, open them again, edit them, also use the source from them. Is extremely handy. And also all these other tools, which I'll introduce you through in this tutorial. One thing too is that it allows you to write notes. So if you make a hashtag and you can say, these are my notes. You see, it shows up as green. R doesn't run anything with a hashtag in front of it. It won't run that line. So if you have a bunch of notes with hashtags and then you have a bunch of code, you can select everything, say, enter, run, and it'll run everything and ignore all the notes, including, let's say you wrote some code that didn't work or you don't want to use it. Just hashtag in front of it and R ignores it. It's just for you. And make lots of notes, lots of notes. It's like writing a little letter to your future self. Your future self will thank you. So let's start by running some simple calculations, right? Try 4 plus 5, enter. Oh, enter does nothing. We have to put our cursor on that line, and then on a PC, it's control enter. On a Mac, it's command enter. And what that does is it sends the code from the script to the console. And we see down here, 4 plus 5 is 9, right? It created something called a vector with one value of 9. Now let's try 3 asterisk 2, control or command enter. 6, that's just 3 times 2. How about 2 to the power of 5? I really should have had this like 5 to the power of 2. It's a little bit more obvious that this is the little hat means go to the power of. So that's 32. And 48, you want to make 48 divided by 3. 48 front slash 3, that's 48 divided by 3 is 16. Or let's say you want a log value. Log, open parentheses. RStudio automatically closes the parentheses for you. Very nice. 32. Control or command enter, and you get the answer down here in the console window. There it is. You're coding in R. No biggie. Notice up here that this is red. It turned red because it hasn't been saved. If I hit Control S or Command S, I think on a Mac that works. Now I've saved it. Save often. Save this, save your files, save your script files. If you make a mistake and R crashes, you don't want to lose hours of work. You want to be able to save it. And save it in a place where you can find it again. Okay. Now we want to be able to import some data from outside of R, right? So in the top right window, you see Environment tab, the Environment tab. And you can go here where it says Import. And use this little drop down to say from Excel. Select from Excel. And then browse to the location for your Tuatara data. Maybe it's in downloads, right? I actually kept mine. I think I have mine in data. Well, let me just go to where I put it just now. Downloads. I have it in downloads. Tuatara Islands R format. All right, that's it. Open. And then R will give us a data preview. We can see there are 2 columns, island and weights. Double means that it's a numeric continuous variable. That's how it's classified automatically by R. It looked at what's inside the column and it said, I think that's what this is. Okay, maybe. And it automatically said first row is names, open data viewer, et cetera, et cetera. And here's the code preview. So basically this step writes this code and executes it for you automatically. This used to be so much harder to do. Yeah, it's actually gotten easier to use R. And then you just click import. And now you have loaded data into R. And you can see in the upper right-hand side, you see Tuatara. And on the left now, it opened up a little spreadsheet version. You can see the islands and the weights. You can see here, islands and weights. There's island 1, island 2, and the weights. And you look at the data on the right-hand side. And if you click that little blue arrow, it shows you, again, that you've got a column, or you see the little $sign? It's like saying that's a column of islands, and it's full of numbers, 1s and 2s. And we have another $sign, another column called weights. And these are all full of numbers. And you can see there are 20 observations of these two variables. Right away, you've got all this data. If you click here, it opens it up as a spreadsheet. Now click back over here on your script. Click back over here on your script, right? Oh yeah, so in the tutorial, when I was walking you through it, it might give you an error message. If it gives you an error message, it's because you need to install a package. You need to install the package library read Excel. I'm going to walk you through how to do that, even though I've already installed it, right? Because we're going to be installing packages a lot. We need to learn how to do this. So if you look at this section here in the tutorial where it says files, plots, packages, help window, that refers to this bottom right hand window here, the files, plots, packages, etc. And you're going to go to where it says install. Packages, packages, click packages, install, right? And then just type in read Excel, XL, and it comes up for you here. You select that, and then you select install. I've already got it installed, so I can't install it again. So I'm going to cancel that, but go ahead and install it. There are 2 steps in using packages. First, install it. When you install it, it installs it on your machine, right? You only have to do it once per machine. If you switch to a different machine, you have to install it again, right? So if you go from using your home laptop to the laptop on campus, you'll have to reinstall it. But once you've got it installed, it's there. Every time you close and open R, you have to load it. So 2 steps, install and load. The loading is something that you can either do by going to where it says packages, and you can search for it, read Excel, and you see how it's checked here. If you uncheck it, that uninstalls it. If you check it, it installs it. Or you can type it in here. You can say, in your script window, library, open parentheses. It does that for you automatically. Read Excel. It already knows what you want. And then you hit Control or Command Enter, run that line, and you install it. 2 ways of doing it, both great. I like to just type it in. I think that's faster, or copy and paste it in. But you can also go over here and check it. Okay, so if you got an error message in importing the data, go back and try again. Again, go over here to the upper right-hand corner, select Import from Excel, browse to your data. Maybe it's in Downloads, Tuatara Islands R format. You see that it's there, islands and weights. Just click Import. Now it's going to open it up as a spreadsheet. Great, you've got it. You've got it in there. Go back to your script file, and we'll go from there. Now we've got our data in. Okay. We're going to start with this data by changing the name. R automatically names it. Let's see if we look at it here. Names it Tuatara Islands R format. That's what the file name was. So that's what it called it. But that's a bit unwieldy for typing. So I want to call it something else. So if you look at the tutorial, everything that's written in blue, you can just copy and paste that code into your script window. Control C, Control V, or Command. I put Control, I'm on a PC, but if you're on a Mac, you know that I mean Command too. That's the same thing, it works, right? Tuatara. So what this script says is take this object, R calls them objects. Once it imported the data in, it made it into what's called an object, a thing. Take this thing, take this object, and this little arrow says, and put it into an object called Tuatara. Take this object called Tuatara Islands R format and put it into an object called Tuatara. Now, if your cursor is on this line, Control Enter, it runs it. And then you can see we now have a new object called just Tuatara. Exactly the same object, same stuff in it, 20 observations, 2 variables, island number, etc. Island is a number, weights is a number, right? The next thing we have to do is part of our data cleaning process. Remember, I said data cleaning is a big part of the process. And that's to change the variable type. So, and remember, we talked about variable type. So we're right away getting into it. So the variable type that R assigned to islands was number. The variables was 1s and 2s. So it thought, okay, those look like numbers. I think these are numbers. And that was a pretty good guess, but it wasn't right in this case. Island 1 is a category. Island 2 is a category. These are not really numbers because Island 2 is not twice Island 1. And right? Island 1 is not half Island 2. they're just the number of the island that we measure. They should also have names, but we didn't, for the purposes of protecting the endangered species, we coded them with numbers instead of giving the islands names. So now we want to change the data type in R to categorical. In R, that's called a factor. So if you go back over to the tutorial and you copy and paste, I would start with the hashtag in green, change data type to factor, copy and paste that over into our script. Again, don't put it down here in the console. Put it up here in the script so you can save it and use it later. Change data type to factor. If your cursor is on this code here, I'll make it so you can see that. Hello, move it. Okay. This is saying, look at this object called Tuatara and the variable inside that object called island, and make it into a factor and store it in the object called Tuatara, the variable called island. That's how you read it. That's what it says. When you run that, you will then look and see in the upper right-hand corner, now on Tuatara Island, right? If you click this little blue arrow, it expands and collapses. Tuatara Island is now a factor with 2 levels, 1s and 2s. Now it sees it kind of as a text file, as a text column. Okay. So we just changed our data type to factor. Now, if we go down through the tutorial a little further, let's see if we can do some calculations, some basic summary statistics, starting with the means, right? So the mean weight of all tuataras from the island. So the mean weight of all tuatara from the island, if we copy and paste that code in here, you can see that it's just mean, open parentheses, tuatara, object, variable, weight. You run that, Control Enter, and you have down here in the console 554.55. So the mean weight of all the tuataras on both islands is about 594, right? But now we actually want to look at the mean weight of the tuatara on each island separately. So, and I'm going to tell you right now, there's an error here, and you're and I kind of left this in there on purpose now because I thought, oh, this is kind of interesting. It helps you to learn. So if you try to run this code here to look at the mean weight of tuatara from each island separately, Control Enter mean tuatara.1 weights, it says tuatara 1 not found. Wait, tuatara 2 not found. Why is tuatara 1 not found and tuatara 2 not found? Because we didn't create them yet. They don't exist. We didn't make them. They don't look. Every object that exists is up here in the right-hand corner in the environment tab. There is no tuatara 1. There's no tuatara 2. We have to make them. And that actually comes in the next step. So that's like an error that I did, but then I thought, I think I'll leave it. So go down over to the tutorial and look at where it says subset the data by island. Copy and paste where it says subset the data by island and put that into your script window, right? And now what this is going to do is actually create tuatara 1 and tuatara 2. It says take tuatara object, and where island is equal to 1, take that and put it in an object called tuatara.1. And if you have the cursor on that line and you Control Enter, it runs it and creates tuatara 1. And then the same thing for tuatara 2. And if you look up here in the environment tab, you now see tuatara 1 exists and tuatara 2 exists. And that tuatara 1 has 13 observations of 2 variables and tuatara 2 has 7 observations of 2 variables, right? So right away, you know there's 13 tuataras on island 1 and 7 on island 2, right? And now we can go up here. Actually, let's change this. Let's put the subset command. Let's move the subset command. I'm going to Control X, Control V, and move it so that first I calculate the weight, then I do the subsetting, right? Because without this subsetting, the mean weight by island doesn't work. Now I can do the mean weight by island, and I can see the mean weight of tuatara on island 1 is 618, and the mean weight of tuatara on island 2 is 551, right? Oh, wow, that's interesting. They're a lot smaller on island 2. I wonder if the habitat's not as good. I wonder. So the next step here would be to get the number, count the number of samples. So count the number of samples. You see where it says count the number of samples? Copy and paste all that code and put it over here into your script. And so this command here, length tuatara weights, counts the number of tuatara sampled total, which is 20, which we already knew. And then this command here, table tuatara island, actually makes a table. It makes a little table down here in console. You can see island 1 has 13. Island 2 has 7, which we saw already from creating tuatara 1 and tuatara 2. It makes a little table with the counts for each category. Yeah, very handy, right? And then if we want to calculate summary statistics for all the tuatara sampled, we can take our summary statistics here, Control C, Control V, summary statistics of all the tuatara on both islands, summary, weights. And now we get quite a few different values. Let me do that again so you can. We get the min, the first quartile, the median, the mean, the third quartile, and the maximum number, the maximum weight. In just one command, we get all these summary statistics. Now let's see if we can get some summary statistics of tuatara from each island separately. So we're going to take summary statistics of tuatara from each island separately. We're going to copy and paste this. Control V. And we're going to say summary Tuatara 1 weights and summary Tuatara 2 weights. And we can see right away the minimum weight for Tuatara 1 down here is 235. And the minimum weight for Tuatara on Island 2 was 320. So they actually are they get smaller on Island 1 than on Island 2. And the max is 836 for Island 1 and 660 for Island 2. And they also get bigger. The mean, as we noted before, was a little bit higher on Island 1 than Island 2. And the median was also bigger. We'll go more into quartiles later. You can also see in this tutorial, I gave you a comment explaining what quartiles mean. So this output tells us a lot, right? And here's a link for more explanations on quartiles and medians. And then there's, if I make this bigger, I wrote a comment explaining it to you in words that make sense to me. So imagine you have a group of friends and you want to know how much money they get for their weekly allowances. Right? Now, if you line up all your friends from the one who gets the least money to the one who gets the most, the first quartile is like the point where the first 25% of your friends are standing. And the third quartile would be where the final 25%, and the median is the person in the middle. Okay, so let's say you have 20 friends. The first quartile would be the amount of money that the fifth friend gets. Sorry. When you line them up from the friend who gets the least to the one who gets the most. It's like a way to divide your friends into 4 equal parts based on how much money they get. And the first quartile is the amount of money that represents the first 25% of them, right? The fifth one would be like every person, all the people on that side, that would be 25% of your friends. So 25% of your friends would get that amount of money or less for their allowance, right? So, and another way of thinking of it is the first quartile helps us understand what the lowest 25% of values are in a set of data. It's like finding out where the starting point is when you arrange them in order. So if we look at Tuatara summary statistics, we can see first quartile is 460. So 25% of the Tuatara on Island 1 are 460 grams or less. And on Island 2, oh, thanks. On Island 2, the first quartile is 513. So 25% of the Tuatara weigh 513.5 grams or less, right? Okay, so this is how, that's medians. And median is the friend in the right in the middle. So the weight for the Tuatara 1 is 690. So if you lined up all the Tuatara from the lightest to the heaviest, the Tuatara in the middle would weigh 690 grams. For Island 1 and for Island 2 would weigh 600 grams. Right from lightest to heaviest, the one right in the middle would weigh 600 grams. So if we want to show this graphically, we could make box plots. We can make box plots. So to make a box plot in R is really easy. You go down to the next page where it says data distribution visualization. Just copy and paste this code that says box plot Tuatara $weights. And when you run that code, yippity skippity, we've just made a graph in R. This is a box plot. This heavy line represents the median. The top of this box is the third quartile, and the bottom of this box is the first quartile. The lower line, the lower bar here is the minimum, and the upper bar here is the maximum. All right. And R makes it really easy now. Instead of looking at the box plot for all the Tuatara from both islands, let's say again, we want to look at these two islands separately. We want to compare them. Maybe one has better habitat than the other. We want to see what's going on there. R makes that really easy. So you go back to your tutorial and you select this box plot Tuatara $weights as a function of Tuatara by island. This this symbol here basically is translated as a function of. So Tuatara weights as a function of Tuatara Island. And when you run that, you see you've got box plots. You've got box plots by island. And right away, you can visually start to see, oh, there's something going on here. Island 1 is a lot more variable, which we saw from the summary statistics, right? The minimum and the maximum range is greater. And also the median is higher. They're larger. The middle Tuatara in the row of Tuataras arranged by weight would be a heavier Tuatara. And on island 2, when you arrange the Tuatara by weight, the middle Tuatara is a lighter Tuatara on island 2 than on island 1, right? Again, the heavy line in the middle is the median. The top line of the box is your third quartile. Your first quartile is the line on the bottom, and you've got your minimum and your maximum. And here we have something called an outlier. This dot here represents an outlier, which is something we'll go into more, but basically it's 1.5, the interquartile range. So the difference between this top line of the box and the bottom line of the box is called the interquartile range. And if you multiply that by 1.5, any number greater than that would be considered an outlier. And it shows up as a dot in the box plot. Okay. We'll go into that more in future classes. You don't have to memorize everything now, just giving you an introduction. So let's also try looking at a histogram. We looked at the histogram in the lecture when we looked at the graphs. Now let's try making one in R. So copy and paste this code hist, open parentheses, Tuatara $weights, and you run that and you get this neat little histogram. This is a histogram of all the Tuatara weights for both islands, right? And you can see the range goes from 200 to about 1,000 or 800 and something. Actually, these bins, I'm not sure. I guess this is 200 to 300. R in this case just automatically cuts up the bins into what it thinks makes sense, but we can change them and modify them. We'll do that in later classes. 200 to 300, 300, 400, 400 to 500, right? So there's one Tuatara that has a weight ranging from 200 to 300. There's one Tuatara that has a weight ranging from 300 to 400. There are 4 Tuatara, 1, 2, 3, 4, that range from 400 to 500. And how many range from 500 to 600? 5, right? You can see how many are in each size class looking at the histogram. And the shape of the histogram tells you something about how the data are distributed. You'll hear this a lot, distributed. But we really want to look and see how the Tuatara look on different islands. So let's actually go back to the tutorial. I've got 2 more chunks of code to run here before we get done. And I'm going faster because my battery's dying on my computer. So copy and paste this over to your script file. It's H1 is equal to histogram of Tuatara 1 weights. H2 is going to store a histogram of island 2 weights. And then we're going to plot them with different colors. Okay, don't worry about what it's all saying right now. Just run it 1, 2, 3, 4, and you will see you'll get a nice overlay of 2 histograms of different colors with I think this is the Tuatara island 1 is in blue and 2 is in pink. And you can see that there's a lot of overlap. They overlap. They're not separate. They're different, but they're overlapping, which we also saw from the box plots. There's a lot of overlap in those distributions. Another way of doing this, just another technique for doing kind of the same thing, instead of putting them on top of each other to make 2 histograms stacked next to each other. Go back to the tutorial and we can use the lattice package, which is pre-installed. You don't have to install it. Copy and paste this code over here. Excuse me. And library lattice will install will load. It's already installed. You just have to load the library of lattice and then do this code histogram weights by island. And you can see 2 histograms next to each other. Useful, right? Now, again,